Here I'm going to set up Linrad 04.00 for the bladerf to receive 460 to 465 MHz. So I click the icon and move this window so we can see it better, perhaps. I tell the system I'm a normal user, that is S. It was originally the letter for setup, S. Font scale, I make it 2. And process priority 0. And I want the screen size in pixels, so I say yes, and specify, let's say 1200 by 600. So this is the screen for Linrad. The hardware is not defined. This is a fresh installation. So I press U. Well, first I press W. In case I make a mistake, I have now saved what I did so far. Then U. And the input settings, A. And bladerf, that's J. That was a trivial error. I had forgotten to install the drive routines for the bladerf. We do that with the sadig.exe, and that should be known to bladerf owners. I allow that. And then U and J. Sorry, A and J. And here we have this bladerf unit. I have only one connected, so it becomes auto-selected. And I don't want to run it through the connector directly into the AD converter, so I answer no on this question. I want 5 MHz bandwidth. That means I want a filter with 5 MHz bandwidth, so I have to sample a bit above that, let's say 8 MHz. 8 MHz. Resampling factor. I don't want to do any resampling. I don't want to run the 8 MHz as it is. So the factor in powers of 2 is 0. Then the Fourier transform bandwidth will be 8 MHz, but I have to enable a filter, yes, and I want the filter to be 5 MHz. Sorry, that is 5000 kHz. Always read the text on the screen before entering things. Actual bandwidth 5 kHz. This is fine, so I press yes. Select gain mode. This does not make a big difference, and I don't really know what I'm looking for. I say here now linearity mode 0. That this will affect the gain distribution. In linearity mode, the gain is high at the AD converter side of the filtering and lower in the front end. So that should give a little bit better resistance against overload problems for signals far away from the passband. And I don't know anything about the frequency error, so I just don't do any correction. The output without port audio to Realtek Digital output, no. HDMI output, no. Loudspeaker, that will be so. Let's make it 19 and latency factor 2. I didn't intend to use port audio, so I repeat this B and use port audio no, and then loudspeaker, that is 0, 0, and then X and save. So let's have a look. We can run in SSB mode, for example, that is D, and we have to go to the parameter screen, and the bandwidth is pretty large. I can make this a little bit larger, let's say 400 Hertz. This gives a transform size of 32,768. And I don't have to worry about optimizations here. So here we are. And I wanted to listen to 460 up to 465. The center would be 462.5. 462.5. Yeah. A little bit more gain. Like that. I send now a signal into the system on 462 megahertz, say. Frequency 462 megahertz. Comes here. There is a mirror image here. So I make some small, I don't need the S meter at the moment. The image suppression is about, it is 20 dB per division, so it is a little bit more than 20 dB, and that's fairly normal. With more, now the signal is minus 90 dBm, and I bring it up in steps of 10 dB. Amplitude increment set 10 dBm, so minus 80, minus 70. Now you can see there are false signals. This is the signal. Here is the mirror. This is the second harmonic of the signal, and this is also the second harmonic of the signal, because the phase relation between the second harmonic signals is not normal like the fundamental. So the mirror image and the second harmonic itself, they may have arbitrary amplitudes. Then there's the third harmonic here and here. I can press A, and we can see that the signal is about 15 decibels from saturations on the AD converter. So I can increase by another 10 dB, like that. And we see the harmonics become stronger. Now, and you can see the margin is about 10 dB. the linearity of this hardware is a little bit limited. Now I can change the frequency, step it downwards in steps of 500 kilohertz. So and of course you can see that when the signal itself, the fundamental, is a little bit higher, the overtones go outside the passband. I only see the signal and the mirror image, and as it happens, it's very weak at this frequency separation. So I further step downwards, down, down, and down, and you can see here is the alias signal, here, here, and it's very weak. We can see it here. The level is now minus 60 dBm. I bring the signal level up, minus 50, minus 40. Here is something. I can step the frequency up again. So now the AD converter is saturated because this strong signal cannot be within the visible passband. So it is an alias signal that we see here. And it's not very strong. The only way to get rid of it is to use a much higher sampling frequency, because then the alias will not be visible. The other way, if we want to avoid aliasing, is to use a narrower filter, but then we wouldn't see 5 megahertz anymore. So I could try, the CPU load is now 70%. I can go a little bit higher, but not very much higher. This is different on different operating systems. The processor has some speed step function. I don't know how fast it runs. It can be anywhere between 1200 megahertz and 3600 megahertz. So X, U, and A and J, and I don't use the J61 connectors. It's no here, and I set the sampling speed higher, let's say 15 megahertz. And no resampling, that's 0. And still 5 megahertz bandwidth. Sorry, I have to say I want to use the filter, yes. And then the bandwidth should be 5 megahertz. And this is okay, yes. And linearity mode still 0. And no frequency correction. Back to the main menu, and don't forget W to save, and then D for SSB mode. And let's make the resolution 1 kilohertz for the first FFT. And now it looks like this. The CPU load is 100%. That's not really what we want. So I press X, change parameters, P, try a different FFT implementation, maybe faster, 2. And then T. It's still 100% CPU load. It could work even it's not 100% all the time, so this could be okay. Probably it is. It's easier now to, while I switch off the loudspeaker. And the mouse is sluggish. That's because of the very high CPU load, and you can see there are underrun errors. So I leave this X and change parameters P, and I go for an easier window function. I just make it a sine function rather than sine squared. That will affect some aliasing spurs in the close frequency range, and that's not what I'm interested to look at for the moment. So zoom the spectrum a little bit. This is what we have. The frequency at the center is 462.5. So I set the generator to 462 megahertz, and it's severely overloaded because this is minus 40 dBm. A. Now we are very close to the overload limit, and you can see the signal 462, it's here, and the center frequency is here, and all the overtones, they stretch far away on both sides of the center frequency. But now when I reduce the frequency from 462 downwards in steps of 0.5 megahertz, you can see how the overtones get out away from the region where we could listen to weak signals. And then when the signal goes out here, it goes down, suppressed by the filter. And now it went outside, and it's coming in here as an alias, and it's still. The signal level is minus 50 dBm, so I bring the signal up, minus 40, 30, minus 20 dBm. You can see the noise floor is going up severely. It is sideband noise, most probably from the bladerf, but there could be some contribution from the signal generator. I have not investigated that yet. Anyway, stepping the signal further down, it is now 452.5, and downwards you can see that the alias here, 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 it is down in the sideband noise of the system. So there are not really any problems with aliasing. When the oversampling is big enough like this, it is nearly a factor of 2. Sampling at 15 megahertz, sorry, it is a factor of 3. Sampling at 15 megahertz for a bandwidth of 5 megahertz. And this is in Windows 7. There are other operating systems where Linrad can use much higher bandwidth, and maybe this can be done also in Windows 7 and all the other operating systems It's about controlling which CPU core is running the different threads and how to have those cores that run the important threads running at the maximum CPU speed. Anyway, I hope this has shown a little bit about the aliasing problems with the bladerf and how they can be handled.